All right, are you ready for some more? It is 10:40 p.m. and I'm still in Seattle. I just went through sort of looking over my notes, making sure I had everything squared away so I could talk about this. And this is going to be a great video. This is absolutely something you want to watch if you're learning Golang web programming, because I'm going to show you how to serve files. In the last video, we looked at how to do routing and RESTful kind of, whoa, did I just move that? Maybe I slid up a slide. Routing and RESTful in Golang web apps. In this one, we're going to see, okay, so previously we were looking at this kind of stuff, right? Where, well, let's go right down to HTTP, right? We are kind of just serving up text. We're serving up text. And so a lot of HTML pages, obviously they're text, and we have to work with text, but we also want to serve up files. Like I want to serve up this image of this dog. And we were serving up that image of that dog previously. Well, heck, I have it right here. We were serving it up previously from Wikimedia. We were just putting in an image tag and then grabbing the image from somewhere else. And some other server on the web was having to serve that image, right? Like we just said, give me this image, put it in my web page, and another server served that image. How do I serve that image from my own server? How do I serve it from my own server? So that's what we're going to learn how to do. And there's a couple of ways we could do it. We could do it with io.Copy, but there's going to be some drawbacks to doing it that way. And then we can do it with http.ServeContent, and that's going to give us a ton of, or a lot more, not flexibility, but a lot more specification, right? Like we're going to be able to specify a lot of stuff in that, and that's going to be better. And then we're going to do http.ServeFile, which will do all the stuff that we did here automatically for us, and we'll look at the source code, the SDK, to see where it does that. And then we will also do a file server, which this serves one file. This serves like, hey, serve this whole directory. Anything in this directory, serve it. Go ahead. I don't care. Serve the hell out of it. That's what file server does. So basic, with a lot of options we could customize, with all that customization sort of done automatically for us, and only a single file, and then a bunch of files, in some location, so we don't have to specify just one. That's what we're looking at. So let's look at io.Copy first. And io.Copy, like I was just saying, like this is being served from Wikimedia. How do I serve it from my own web page? Well, the first thing I might try doing is putting in image source and then just serving that file. So if I look at our code here, this is the second one, and I have image source right here. And I have Toby right there, and that's right at my root. And so I say, hey, right in my root, serve that file. But when I run this, it doesn't work. And you can see that in the presentation, right? I go to localhost dog, and now dog is going to run. And when dog runs, it calls uptown, and uptown has to be a handler func, and so it has to have the signature, and that's what it is. And okay, cool. Uptown runs, and I set a header, and I get the name. And then I say dog name, and if there's a dog name added on here, it should print that out. And then I write string, and that's where the dog name comes. And here I ask for the image, but it's like, I don't know what you're asking for. I don't know how to serve that. So that's not working. How do I get it working? I could try, first of all, doing a little troubleshooting. And so here I'm doing HTTP handle func. Before I was using HTTP handle func. Here I'm doing HTTP handle func for anything at the base root, right? I'm going to run this function. So here's my handler func, and I just stuck this one right in line. I could have extracted it and given it a name like this one and put it up here. But right here I'm just saying print line the request URL. And so this shows me every request that comes in. It's saying, hey, Toby.jpg, I had a request for that from right here, and that wasn't handled anywhere else. And fave icon. ICO, that's just like the little icons that show up right here and right there and right there. The request for that came in. And then also right here you can see a request for /dog/ came in. That got handled right here by Uptown, and that ran all of this. And you can see that that's what the output was. So anything that wasn't handled by this right here goes to that. And that's how that ran. But this is a troubleshooting step. So we could just kind of see what are the requests coming into the server. And then finally I'm like, okay, let me use io.Copy. So I create a new route, and I know that when I go to /dog/Toby, that's going to resolve to, well, will it resolve to this one? No, that doesn't match. Will it resolve to this one? Yeah, because dog is the most specific route that matches right here. And I don't think I ever really explained the route matching in all of it in one, just like, hey, I'm going to explain route matching. But I think you probably got the idea, because I know I've shown what happens without this / and with the /. So anyhow, this matches to dog. Then dog is going to run uptown. Uptown runs, sets a header, pull the name out, right? So we get that name thing here, which we talked about, and then we print the name right there. So there's the name Toby, and then we say, hey, image source / Toby, like I want to serve that image, and kabam, that image serves. So when this line of code runs, that's another request to the server, and then the server gets this request and / Toby. Well, heck, that's right here. I'm going to run / Toby. The handler func is dogpick, and then dogpick. What it does is it opens the file. So, we get a pointer to a file and an error, and we check the error to make sure that there's no error. If there is an error, we write back http error, response, file not found, 404, and then we return, and that takes us out of this function. If there's no error, we don't do any of that, and we defer closing the file, which means that this is going to run when this function's exits. Anytime you see defer, it means run this chunk of code right at the very last moment before this function exits, wherever defer is in, whatever function defers in. That's what defer does. It defers until the end of the function, and then it runs it. So it's going to close this right when the function closes. That's kind of cool, because you could open a file, and if you need to close it, you just put it right next to where you opened it, and you can see that that's connected. You can see, did I close this? Oh yeah, it's right there. You don't have to look all over for it. Helps keep you, keeping up with good coding practices. And then finally, we have io.Copy, where we copy to the response that file. And io.Copy takes a source and a destination. No, a destination and a source. And the source right here, if we look at io.Copy, what do you think that has to implement? What's that going to implement, right? What's this one going to implement? I'm thinking, since this one's writing, it has to implement the writer interface. And since this one's reading, and this is the destination, this is the source, this needs to implement maybe the reader interface. So if we go look at io.Copy, godoc.org, and this is just like, hey, can we understand what's going on? And here we have io.Copy and destination writer and then source reader, right? So that's the two things that io.Copy needs, and needs a writer and a reader. If we look at what a reader is, and then it returns the number, what was written, how many bytes or whatever written, and then an error. I say whatever because it's like, where does it tell us what it returns? Copies from source to distribution until end of file is reached. On source, it returns the number of bytes copied. So that's copy, and then we know the reader interface. But what is it right here that makes a file implement the reader interface? So file comes like, there's OS open, so we could go to OS, package OS, and I'm just belaboring this point because I think it's really important to know how to work with the docs. And when you know how to work with the docs, you can start to come in and start piecing things together and say, okay, this has got that, this has got that. I can put those pieces together. And so here we have a file, type file, right? And right here, when we do OS open, all right, we got to go to OS open first. Open. Okay, so it is right there. When we do OS open, we get a pointer to a file, right? So we do OS, package OS, .open. That's kind of funny. It seems like I almost want to say it should just be, but I guess that's the right place. Sorry, I'm just having a little bit of a brain fart myself. But OS open, because sometimes it's like, okay, that's a file, but I guess it's just as categorized under the file. Yeah, that's right, because then these are the methods right here. Okay, late brain, sorry about that. All right, so here we have OS open, and that gives us a pointer to file, which means we have all of these methods right here available to us. Right, and what is OS open? Gives us a pointer to a file. We need to make sure that since io.Copy takes both a writer and a reader, we need to make sure that the pointer to a file that we got is a reader, so it could go in there. And what makes it implement the read interface? Here's read, b slice of bytes, int error, and that helps it implement. Or that's what causes it. Having that method causes a file, right, a pointer to a file to implement the reader interface. All right, so there's a long-winded description of why this, right, will work and why we can pass a file in there. So this just copies, right, that to this, and it's writing it to the response, and so it's copying this entire file to the response. Pretty cool. It's reading it and then writing it to the response, and that prints it out. And so that's using io.Copy. And here, as you saw in there, that we did that error checking right here. And I just wanted to provide that documentation so you don't have to go look it up. But here we get the response writer, the error string, and the code. It needs a response writer because it's writing it back to the client, right? Response writer, it's writing it back as the response to the client. It gives a description and then the error code. It gives a description, error string, and then the code, right? So that's how the error works. Now there's a problem with doing io.Copy, and we should be setting the content type, and we're not. We should be setting an e tag, and we're not. And we could do all of this manually, but there's a much easier way to do it. And that's with using http.ServeContent. Yeah, baby. Yeah, 1033. Here we go, http.ServeContent. So how does http.ServeContent work? So ServeContent fills in the headers for you, and you can put in all this stuff right here. So here's like the new code. I'm going to need some information about the file, so I run fstat. What is fstat? Well, if I go back and look at OS here, when I get my pointer to a file, when I do open, I get a pointer to file. I have all these methods. Stat is one of the methods, and it gives me file info and an error. File info, right, gives me the name, the size, the mode, right, and the modification time. When was this file last modified? Is it a directory? Woo, that's cool, right? Because now I can start like searching through directories and files and figuring out which is which. So the main thing though, mod time, name, when was the file last modified? That's really important in web programming. So fstat gives us, this file information, and if there's an error, we return an error. Otherwise, we do ServeContent, and ServeContent's going to write back a response, so it needs that. It's going to need the request, so it could read, hey, were there any e tags or anything in the request? It's going to want the file name, so we give it the file name. It'll want to know when the file was last modified. And finally, what is F? F is the file. It's going to need the file. And then it'll serve all that back with all the appropriate headers. Kind of a pain to write all that stuff and understand it, but a lot easier than doing it with io.Copy and putting all that stuff in manually. So here it kind of breaks out what I just told you. Like here's ServeContent needs the request to look at the request that came in to see if there's an e tag and everything. And then it needs the name of the file and the last time the file was modified. And then finally, it needs the file, and the file needs to implement the read seeker interface. What's the read seeker interface? When we were dealing with io.Copy, it needed reader and writer, and we saw that the file implemented, right? No, I just hit back. The file implemented the reader interface because it had this read method, and so we were able just to pass, a pointer to a file into copy where it wanted a reader, and then we pass this in right there because it wanted a writer. So that worked there. But now we're looking at ServeContent, and it is wanting a read seeker. It's wanting a read seeker. We'll come back to this in a second since I'm already talking about this. So a read seeker is it implements a reader and a seeker, and that's the reader interface and the seeker interface. And this is in package IO. So if I go to godoc.org and IO, I can look for read seeker. I want to start singing like that song from The Who, I think. They call me the seeker. Read seeker, read seeker, read seeker, sorry. Read seeker. And what is a reader? Boom, that's a reader. So I need a reader and I need a seeker. What is a seeker? There's a seeker, and it needs to have this method. All right, no big deal. I'm understanding how this works. So here's reader, right? It needs a reader, and it needs a seeker, and it needs a seeker. So it needs that interface. So if I'm going to pass where does it need the read seeker? Here at the end, if I'm going to pass a file in here, the file needs to implement both the reader interface, which we already know it does, and it needs to implement the seeker interface. Before I even understand seeker, I could just say, hey, does a file implement that seek offset int 64 whence int returned int 64 error and offset int 64 whence int 64 error. So cool. File also implements the read seeker interface. So what exactly is ServeContent doing? And we'll understand that a little bit more. ServeContent replies to the request using the content in the provided read seeker. Cool. The main benefit of ServeContent over io.Copy is that it handles range requests properly. All right. Sets the MIME type. Okay, cool. File type. And handles if modified since requests. Okay, cool. So like if they're saying, hey, if this has been modified since this date, send it. But if not, I don't need a copy. I already got it. So the way web servers work, a client makes a request, and the way e-tags work, and you could look this up online, but a client makes a request, and then it's like, send me this picture, and I currently have one on file, and the one I have on file the last time it was modified was August 2015, August 1st, 2015. And if yours is newer, send me the new one. Otherwise, I already got the picture. And so the server will look at that and say, nope, the file you have is the file I have. I don't need to send it to you again. Just use the one on your computer. Or, oh no, I have a newer one, the server might say, and then serve the new file back. So that's how that works. If the response's content type header is not set, so if the content type header is not set, ServeContent tries to deduce the type from the name's file extension, and if that fails, falls back to reading the first block of the content, passing it to detect content type. So that's, it detects the content if the content type isn't set and writes the content type. If mod time is not 0 time or Unix, ServeContent includes it in the last modified header in the response, right? So if you include a last modified time, ServeContent includes it. The content seek method must work. ServeContent uses seek to the end of the content to determine its size. Okay, so that's how it figures out the size, right? It uses seek before it sends it. So you can see that OS file implements the read seeker interface, and we just checked that out and verified that ourselves. All right, so that's what seeker basically does, is allows read content to seek to the end of the file and see how big is this file. All right, and this is where same documentation we just looked at. Okay, cool. It implements the seeker interface. And then here we have, so we got, let's see, we have file stat. And so this is just me showing you that when you go, you run file stat like we did right here, fstat, right? You get file info, and file info is all that stuff. So we just looked at that too. So that's one way you could do it. And what we've just looked at are, we did io.Copy, and then we also did http.ServeContent. Now we're going to look at http.ServeFile. And so I have that right here. An even better, easier way, http.ServeFile. So it's going to figure it all out for you. And func.ServeFile takes a response writer, a request, pointer to a request, and then a name, right? ServeFile replies to the request with the contents of the named file or directory. Named file or directory, As a special case, ServeFile redirects any request where our URL path ends in index.html to the same path without the final index.html. To avoid such redirects, either modify the path or use ServeContent. Oh, wow, that's cool. So we do ServeFile on a folder and we have index.html in there. It'll automatically serve that when people just go to /. I think that's what that says. I haven't tried it. Check it out for yourself. All right, so let's see ServeFile in action. And so here we have handle func at this route, handle func at this route. When somebody goes to dog, right, /Toby, or just anything that matches, right? Dog /Toby matches this, so Uptown runs. Set my header content type. Do my dog name thing where I pull out that and show Toby right there, dog name Toby. And then I'm also going to image source /Toby, sends another request to the server. The server says, okay, which path does that match? It matches this path. It runs dogpick. Here's the handler func. Dogpick is a handler func right there. It has that signature. http.ServeFile response, request, Toby, JPEG. Cool. That's pretty easy. And, two things to talk about here is, first of all, check this out. I'm saying I want this. This might be a little confusing. I want, when somebody goes to this path, then it runs this URL, which then runs this handler func. And when they run that, check it out, right? It's saying serve this file. Well, why isn't that / since I asked for /? You might think that. But remember, the route doesn't translate, whatever somebody asked for in the URL. The URL doesn't have to translate at all in any way to some file. And when I'm serving some file, right, I'm serving Toby JPEG. And where is Toby JPEG but right at the root of my server, right? So, Toby JPEG is right here. So let's go, I'm confusing myself. Let's go look at that and just see it in action and play with it for a minute until we're clear. No, ServeContent, ServeFile, and there's Toby JPEG, and I am in 06. Cool, I'm in 06 right here, and I'm going to just restart my server, Control-C. Okay. All right, so I just restarted 06 ServeFile. I just opened up ServeFile, and now when I come to localhost 9000, that should all run. HTTP not found, because I need to put in some forward slash. If I do /dog, does that run? There we go, /dog, and it defaulted. And if I add a name in there, Toby adds the name in. That's pretty cool. I could do and more stuff or whatever. Hey, just grab that one argument. That's pretty slick. I forgot we did that. All right, and so now, right, I'm going to change this. Let me add a / in there, /Toby, and then Control-C, and then start it again. Come back here, nothing, right? Won't serve the image. What about if I add Toby in like an image folder? Image, and let's drag Toby in there. And I'll just actually make a copy of Toby and leave him here too. That might be confusing, but we'll just keep it like this for the example. And then to get to that, I'm going to have to go to image /Toby. Is that right? Ask yourself the question. And come here and refresh. Nothing. What about if it's like this? Oh, I got to restart. Whoa. Whoa. Cool, so that worked. So for whatever reason, right, it doesn't like the / right there in the file name, right? When it's asking for, hey, where's this file or what is the name of it? The name of this file is like, if it's just at my root, it's just the name of the file. So, you know, that's the way you kind of like learn about this stuff, is just like ask yourself a question, go in and experiment and see what happens. And then pretty soon you're like, okay, that's the way that works. I don't know. I don't think that explained it very well. I wish I had a more logical explanation. Let me think about this for 1 second, see if I come up with anything. Okay, so this is what I came up with. ServeFile is serving files from the current directory in which you are running or executing this program. And inside that current directory where you're running and executing this program, there's also this folder. And if it's not in that folder, right, then we went into another folder before we had it also like this, right? Maybe I never even changed it. We had it like this, right? And so if I'm in that current directory right here, I'm running it from this current directory. I'm running it from 06 ServeFile. That's where everything's running from. If I had another folder image, I'd just say, hey, go into image and then go into here. If it's just the image in that current directory, then there's the name of the image in that current directory, right? And so here, Toby's right there. And so that's how that's working. So hopefully that's a little bit of a better description. Just took me a second to find the right way to say it. All right, so that's http ServeFile. And the other thing which I want to point out, I said there's two things to point out about that, is like, well, am I also, and this was the question I asked myself, am I also getting all that other stuff done that I had when I was doing ServeContent, right? When I did ServeContent, I had all this other stuff, file name, mod time, and everything like that. Is that stuff occurring when I'm doing ServeFile, or is it just serving the file, not including the, you know, the mod time and the file name and all that other info? And so I went into the docs, and let's see if we could find that. And what I started looking for first, where would be the first place to start out? Let me ask you that question. Where would be the first place to start out? Does ServeFile also include that header information like etag? Well, I'd want to go to the HTTP package and look up ServeFile. So let's go to the HTTP package and look up ServeFile. Not there. I've got a lot of stuff open. iOS, okay. Godoc.org, nethttp, and find ServeFile. And then we could go look at ServeFile. And then we could say, okay, read it, and it doesn't tell us anything more. We could go look at the code. So click that. And here is ServeFile, and ServeFile has that signature which we were using, right? So here's ServeFile, response request, and then the file name, and then it says file path split name. Okay, so then it gives me this stuff, directory, and then we have ServeFile, and look at this, dir file false. So I could Control-C, Control-F, and this is a capital ServeFile, and this is a lowercase. And so because they have a different, I mean, Go is case sensitive, right? And so since we have different case here, these are different functions. And so if I look for ServeFile, there we go, I can find, here's the lowercase serve file, which takes a response writer, a request, a file system, a name, a string, a redirect, and this is all happening for us in the background on its own when we call serve file and only pass in that, right? It then calls this function, and what we're looking for is, hey, check this out, open the file, get fstat, right? And then somewhere after fstat, I'll bet we'll be doing, whatever that other stuff was when we did the serve content. Right, so what was that other stuff? Mod time, fname. So I wonder if mod time is in there. Mod time. So maybe somewhere in there, mod time is in there. I don't know where fstat just went. There's serve file, and here we have some mod time stuff going on. So serve content mod time. So you don't have to understand all of the code, but it's like, okay, that looks kind of like similar to what we were doing, in the previous one. Pretty cool. All right, so the next thing is we were just looking at that serve content, and now we're just looking at serve file, and there's serve file, and we just sort of like took that apart and understood why it's like this without slashes, and then we also took a look and saw, hey, does this also do the thing that serve content did for us? So the last thing to look at is yet still an even better, easier way, which is an http file server, and file server lets you serve like a whole directory. And so here, let's see, I've got file server, right? So we have handle, and it takes a route and then a handler. So this must be a handler. And if we go and look at go.Doc file server, there we go. File server returns a handler, right? So when file server goes, file server returns a handler that serves HTTP requests with the contents of the file system rooted at root, and here's the root, right? And then this takes a file system, and a file system is an interface, and it needs to have open, this open method that returns those two things. All right, so let's take a look, see how that's being used. So we have HTTP file server, and then we have http dir and there. And so http dir, excuse me, type dir right here has open name string file, right? And we were just looking at that a file server takes file system is an interface that has open all that, and we just saw that dir implements that. So when we have a type dir, right, when we use that, it implements this open function, type dir. Type dir is a string, so this is, what do they call that? This is the base type. The string is the base type. And so this is a type, and the type is dir, and its base type is string. Sometimes getting just the right. Go is a language that has a language all its own. So there's a language for talking about the language, which is Go. And just getting the verbiage right is sometimes tricky because it's not the same way you would talk about other programming languages. All right, that said, we have HTTP file server, and then we have HTTP dir, and then we just pass in dot, which is like the current place where the current directory where this program is running. So HTTP dir has attached to it the method open, and because it has the method open attached to it, method open is attached to it. It is file system, implements the file system interface, so it implements the file system interface, and because it implements the file system interface, we could pass it into file server, right? And so file server needs something that implements the file system interface, and HTTP dir implements the file system interface, and that's making this. And this right here, this isn't a function. That's not a function. This is conversion. This is conversion. So we're converting this string to a type dir, and type dir implements that that interface where you need it open, file system interface, right? And so this is implementing the file system interface, and that's what file server needs. And then file server returns a handler, and a handler is what this needs. It needs that and a handler. And so you might be like, oh my gosh, how did you ever figure that out? I didn't. I had somebody show it to me, and I could see like how it works, but I didn't sit there and figure it out. But once you start understanding how this stuff works, you then start to gain the capability to be like, oh, I need this, I need that, can I do that? Okay, cool, it's running. All right. So that's HTTP handle and running a file server. And so now what happens? I go to dog/Toby, and so that implements this one. And Uptown runs, and it comes down and goes through all this, and it writes, and then it prints out the dog's name, and then it says, hey, I need this. It sends a request to the server, and the server serves that. The server just serves that file server. It serves it. So it's serving everything at root. And then you'll also notice, however, when I go to localhost 9000 and just ask for the file, main.go, it serves that. Because this serves everything, right? So maybe not exactly what you're looking for. So how could we just restrict this to a certain directory? Yeah, I don't know if you want to see that in action. It's kind of cool, actually. So every now and then I just have this fear that, am I still recording? I am. So here's file server, right? And it's serving to root. And so let me change into that. That's 7. I got it. Oh, good. I'm stopped. And go run main. And so that's running. And so I could go to localhost 9000 /dog/Toby. And it brings up Toby. But this file is also right here. My server's running right in this folder, right? And so if I say, all right, well, I want to see main.go. Kapow. It served that file. It served the text, right? Because the type on this is content type text plain, right? So it just like said, oh, it looked at the file and said, this is just plain text. There's no HTML in here. There's no doc type at the top. And so it set content type to text plain for me, and it just served up text. But that's kind of nuts, man. You can see all the source code of my website if I set my website that way. All right, interesting stuff. How do we serve just a certain folder? And let's say I had a folder over here. I don't. I have a folder called assets, right? But and this is interesting actually. So I have a folder assets right here, and I'm saying I want to serve. I'm going to make this. I want to make this this folder assets. I'm going to use conversion to make that a type dir, right? So that's type dir. And since this is type dir, it implements that. What was it called? The file something interface. File system interface, right? Since that's type dir, it implements the file system interface. File server needs a file system interface, and I am now serving, right? HTTP file, I'm now serving from this folder. All right, so the next thing is in my code, and this is trippy, in my code I said, hey, from this, at this location, I want you to serve this file. Well, remember that URLs do not map in any way to any resource on your server. The only thing URLs do is they're like a key that unlocks certain code that should run. So this key right here is unlocking this code, right? It's, you know, when somebody goes to this path, so when the server receives this request, give me this, it goes and looks like and says which route handles this. This route handles it, right? So now this is going to run. Handle takes the route, and then the handler, and this is all the handler right here. And what's the handler doing? The handler is saying, hey, you know what? Strip off resources. I don't need that. And all I need is, you know, this part right here, Toby, I guess it's /Toby JPEG, right? We'll see, right? We'll play with that. /Toby JPEG, because /resources got stripped off, which left /Toby JPEG. I need /Toby JPEG served from this folder. Well, when I look in that folder, there's Toby JPEG, right? So that should be right? Because it's assets /Toby JPEG, right? And there it is, right there. So that's how you'd read that. If we didn't strip this off, right, it would try to serve. Let's say we go here, we go to this path, and then it's going to look in here. It's going to look in this assets folder for resources Toby JPEG. So everything I just explained there is kind of what I wrote up here and down here and right here. So if you want, you can pause that video. I know it's a little bit of a trip to wrap your head around, and I laid it out this way because it's even more of a trip to wrap your head around when you try to read it like this, where you actually have an assets folder. Let me just show you that over here. Right here. it's even more of a trip to read it this way. So there's the resources one. Where's my assets one? Assets, assets, assets. Okay, so they're not. It's even more of a trip to read this way when it's assets, 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 assets. You're like, what is going on, right? So I just thought that this other way of explaining it right here, where you can kind of see, okay, this is just, you know, URL, and URL means this code runs, and then, you know, what I want to serve is just this part, so I need to strip that off, and it's going to serve it from this location. I think that's the best way to think about this. Anyhow, what's going on with all of this stuff, the HTTP prefix and everything in there? How do you understand that? Well, here is that same thing, so we could reference it, right? HTTP handle at this URL, and then we do HTTP strip prefix, file server, all of that. And then these things from the code up here sort of explain how this all works. And so handle takes a string and a handler. So string, and this is all a handler right here. This is all a handler. And this handler, right, it means that it's implementing the handler interface, which is right here. And then we see that strip prefix right here, when we look up type handler, strip prefix returns a handler. So that means that this is all a handler right here, right? Strip prefix and everything there returns a handler. And this handle needed a path, a URL, right? And a handler. So we're getting a handler from strip prefix because that's what it returns. And strip prefix, when you look it up, takes a string and a handler. Oh, another handler. So it takes a string, right? That's what's going to be stripped, and then another handler. And we already saw how this is a handler right here, right? And then you can see removing the given prefix from the request URL's path by invoking the handler H. So, you know, and invoking the handler H. It removes that prefix and then invokes this handler. And so then we have a file server, and a file server takes a file system, and a file system has this method, and dir is a type with an underlying type of string, and it implements file system, and you can see dir implementing file system, and since dir implements file system, it could go in here. So when we use conversion and convert the string to type dir, right, it's implementing the file system interface. I know we already did this, but I just thought I'd keep going because it's here and it's a good way to see it. It's implementing the file system, so it could go in here, and then file server returns a handler, and strip prefix you know, was a string and a handler, and that returns a handler, which is what this is all. So it's pretty awesome. All right, so that's a HTTP file server and how it works. So here's an exercise for you, which I'm going to show you the solution to, but if you want to try it on your own, you can pause the video and do that right now. Create a static HTTP server that serves the contents of the current working directory. So how do you do that? How do you create a static HTTP server that serves the contents of the current working directory? Good challenge. Here's the solution. Log fatal. HTTP listen and serve. Right here is the route, and then here's the handler. We could do it right at root. There's nothing to strip off because, you know, you could go back and look at the code, but we're just serving it right at the root. So we're not saying you need to strip off any folders or anything like that, because every folder that comes in as a request just goes straight from the root. And then log fatal here is just something that you could do that would catch it if this blew an error. I wonder actually if we took log fatal off if it works, so I think we'll go try that out here. But when you do that, you could do localhost 9000, you could run this, and you could see wherever you run it from the whole kabang of everything. So let's go play with that. And notice I had to do go install. So I went go install, and then I went to a different location, and I ran the file from that location. So let's go check that out. And then it'll be not bedtime, but Miller time. All right, so here it is. Close my current server and change directories and go into 10. And then I'm gonna I could do go run main, and what's going on, right? 9000. Let's go see what's happening. Localhost 9000 main.go. That's it, right? And then it shows me that. So that kind of worked. But I could also do this. Go install. When I run go install, just as a little bit of a reminder, it's going to go to my workspace, and then in my bin, it's going to drop. Look at all these other binaries. It's going to drop it into here. So let's run go install and go look in there. Aha, there it is. Right, so now this is an executable, and since in my terminal go env, right? Since I have, so here's my workspace, and actually I want to see env. And then my environment variables are, one of them is pointing to right here. No, that's not what I'm looking for. User local go bin. Dun, 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 dun. This is what I'm looking for right now. Is that it? There we go. So here, users TMO2 documents go bin, so that's a path pointing to this folder with this executable. That means anytime I type in a file, one of the places it'll look to see if that file is there is right there. So now I could go to any directory, and currently I'm here, but let's change into documents, and or we could documents. Where are my downloads? Yeah, cool. Change in downloads, and I can now type in the name of this program. 10 static file server, and just hit it, right? And so that is now running from this directory, right, which is my downloads. I never closed this one. I don't know. Oh, I did close that, and this one's still running. Cool. So now I could go to localhost 9000, and this is showing me my downloads, and I could, look in there if I want, and it's serving different folders. So yeah, there's some video files. Pretty cool. Anyhow, close that server, Control C, and come back here. We were going to see if log fatal, what happens if we take that off. And then we can look up log fatal. So we'll take off log fatal and then try running it again here, just from our root, and import and not use log, and you get rid of that. Try it again. And let's just go to this again, hit refresh. Hey, so it still runs with the log fatal. So I'm going to put log fatal back in. And I could click on log fatal and see what log fatal does. And the way you do that in WebStorm is hold down command and click on fatal right there. Anytime you hold down command, you can fly over stuff and it becomes hyperlink and takes you to the code. It's totally cool. So here's fatal is an equivalent to print followed by call to OS exit 1. So fatal takes any type and an unlimited amount of them, and standard output 2, format sprint, and OS exit 1, and that's part of log.go. So log fatal. Interesting. All right, so it just logs it if there's some error. I kind of like it better without it, but this is the way it was shown to me when I was learning. So I think I'll make 2 versions. Anyhow, it's late. I'm rambling. And I'm going to make the second version. And then, there we go. The first version will be without the log. That way we got all the archived code. Because that works too, man. It's actually a better way to present it. All right. Thank you very much for watching. And I hope that you learned something great. Despite my rambly lengthiness, I'm going to quote Blaise Pascal and share a little poetry with you all. And then also, since you hung out so long with me, I'm going to share something else. So this is Blaise Pascal. I've made this letter longer than usual because I lacked the time to make it shorter. Isn't that awesome? I've made this video longer than usual because I lacked the time to make it shorter. So despite the length of the video, I hope you learned some good stuff. Kind words do not cost much, yet they accomplish much. Do not cost much, yet they accomplish much. So, cool stuff. Last thing I wanted to share, one thing today, I'm just going to randomly show you something. Amazon and T. Scott McLeod. So before I really threw myself into programming, I was really into like humanities and literature and writing, and I wrote all these books. So trip out on that, right? I wrote like over 45 novels, and 20 of them or so are published. But anyhow, they're really wacky novels. I had a pretty tough childhood. I was raised pretty hard, and anyhow, these stories were just like a way of me coming to terms with all that. So some really cool stuff. And yeah, anyhow, I wrote this one poem today, just randomly, dude, because it's late and I've had a couple of beers, and you're still here. I'm gonna share it with you. And it's kind of about being a good student, but let me see where to go. I thought I page, here it is. The higher you go, the harder it becomes to admit you don't know. The more you admit you don't know, the higher you go. So just check that out for a second, right? I think it's pretty cool. I'm going to type it up. Here, actually, I've got it somewhere else. Hold on. All right, here it is, how I wrote it out this afternoon. The higher you go, the harder it becomes to admit you don't know. The more you admit you don't know, the higher you go. That's the path to becoming an expert. It's a bit of a Zen paradox, right? But the higher you go, the harder it becomes to admit you don't know. The more you admit you don't know, the higher you go. You have to admit you don't know if you want to learn, right? And if you learn, you're going to go higher. Yet as you go higher, it becomes harder to admit you don't know, which means you're not going to go higher, you're not going to learn. So it's like a really cool paradox. I just really like the way that came to me. I thought of that today when I was hanging out with my friend Bill Kennedy, and he was blowing my mind with a bunch of Go stuff. And I was just like, it was hard for me to admit I didn't know to Bill. You know, I was like, oh, I don't get it, dude. I don't know. But I had to, right? If I wanted to go higher, I have to admit it. All right, anyhow, thanks for tuning in. Like this video if it worked for you. Thank you.